So guys, in today's session we are going to see the next element of your group 16, that is your sulphur. Okay, sulphur. So to begin our session, first of all we are going to understand the allotropes forms of your sulphur. So the first topic of today's session we are going to see is your allotropes of sulphur. Of course, many of you may be having a doubt, what do you mean by allotropes? Though I have explained in my earlier sessions. Once again I will say you. So allotropes means they are the different forms of the same element. ಏನು ಹೇಳುತ್ತೆ, ಎಲಿಮೆಂಟು ಅದೇ ಆಗಿರುತ್ತೆ, ಅದೇ ಅದ್ರ ಸ್ಟ್ರಕ್ಚರ್ ಗಳು ಏನಾಗುತ್ತೆ ಇರುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಾವು ನಮ್ಮ ಫಸ್ಟ್ ಇಯರ್ PUC ನೋಡಿದ್ವಿ, ಕಾರ್ಬನ್ ಡಿಫ್ರೆಂಟ್ ಎಲೆಕ್ಟ್ರೋಪ್ಸ್ ಯಾವ್ದಾದಿತ್ತು. ಒನ್ ವಾಸ್ ಯುವರ್ ಗ್ರಫೈಟ್, ಅನದರ್ ವಾಸ್ ಯುವರ್ ಡೈಮಂಡ್, ಅನದರ್ ವಾಸ್ ಯುವರ್ ಫುಲರಿನ್. ಅಫ್ಕೋರ್ಸ್ ಅಲ್ಲಿ ಇರೋದು ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವುದು ಕಾರ್ಬನ್. ಆದ್ರೆ ಮೇನ್ ಡಿಫ್ರೆನ್ಸ್ ಏನಿತ್ತು ಇವೆಲ್ಲ ಮೂರು ಎಲೆಕ್ಟ್ರೋಪ್ ಅಲ್ಲಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಯರ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ವಾ. ಸೊ ಸೇಮ್ ಎಲಿಮೆಂಟ್ ಇದ್ದಿ ಡಿಫ್ರೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಇದ್ರೆ ಆ ಒಂದು ಅದನ್ನೇ ನಾವೇನಂತ ಹೇಳೋದು, ಎಲೆಕ್ಟ್ರೋಪ್ಸ್ ಅಂತ ಹೇಳೋದು. ಸೊ ಕಮಿಂಗ್ ವಿತ್ ದಿ ಸಲ್ಫರ್ ಎಲೆಕ್ಟ್ರೋಪ್ಸ್, ಬೇಸಿಕಲಿ ಸಲ್ಫರ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಮೆನಿ ಎಲೆಕ್ಟ್ರೋಪ್ಸ್, ಬಟ್ among them we will be considering only two most important allotropes of the sulfur. One is your rhombic sulfur. Okay, one is your rhombic sulfur, which is also called as alpha sulfur, and the second part is your monoclinic sulfur, which is also called as that of your beta sulfur, Okay, so mainly we are going to study about these two types of the allotropes of your sulfur. One is your rhombic sulfur, which is called as alpha sulfur. Similarly, is a monoclinic, which is called as that of your beta sulfur. So the main attention in our syllabus part is to understand what are the properties of your rhombic and that of your monoclinic sulfur. So to begin with, the first important property we are going to see about the rhombic sulfur is its melting point, which is in the range of nearly 35.8 Kelvin. Okay. And coming with respect to its preparation, basically rhombic sulfur crystals are formed by evaporating. What they are saying, by evaporating the solution of roll sulfur anta ಹೇಳ್ತಾರೆ. Okay, roll sulfur in CS2. ಇಲ್ಲಿಗ ನ್ಯೂ ಟರ್ಮ್ ಏನು ಅಂದ್ರೆ ಸಲ್ಫರ್ ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತು, ಬಟ್ ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ದಿಸ್ ರೋಲ್? ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಏನ್ ಮಾಡಿರ್ತೀವಿ ಅಂದ್ರೆ ಮೋಲ್ಟನ್ ರೀತಿಲಿ ಸಲ್ಫರ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಅದನ್ನ ನಾವು ರಾಡ್ಸ್ ಮತ್ತೆ ಸ್ಟಿಕ್ಸ್ ಶೇಪ್ ಕೊಟ್ಟಿರ್ತೀವಿ. ಓಕೆ, ಏನ್ ಮಾಡಿರ್ತೀವಿ, ಈ ತರ ಸಲ್ಫರ್ ನ ಮೌಲ್ಡ್ ಮಾಡಿ ರಾಡ್ ರೀತಿ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ. ಸೊ ಇದನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಡಿಕಂಪೋಸ್ ಮಾಡಿ ಹೀಟ್ ಮಾಡಿ ಇದನ್ನ ನಾವು ಇವಾಪರೇಟ್ ಮಾಡಿದಾಗ ನಮಗ್ ಬರೋ ಕ್ರಿಸ್ಟಲ್ಸ್ ಯಾವ್ದಾಗಿರುತ್ತೆ, ನಿಮ್ಮ ರೋಂಬಿಕ್ ಸಲ್ಫರ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಬೇಸಿಕಲಿ ಇದನ್ನ ನಾವು ಮಾಡೋದು ಯಾವ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ, ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಇಟ್ ಇನ್ ಅ ಕಾರ್ಬನ್ ಸಲ್ಫೈಡ್, ದಟ್ ಈಸ್ ಯೋರ್ CS2. ಓಕೆ, coming to the next property is with respect to its solubility in water. Remember, your rhombic sulfur is insoluble in water. What we are saying, the rhombic sulfur is insoluble in water. But do remember, this rhombic sulfur somewhat, not completely, we can say that to some extent, they are soluble in that of your benzene, alcohol and ether. To some extent, they are soluble in your benzene, alcohol and ether. But they are readily soluble in carbon disulfide. Adhe reason ikoskarane when we are preparing your rhombic sulfur, we are using the solvent as that of your CS2. Coming with respect to the another allotrope of your sulfur is your monoclinic sulfur. Okay, monoclinic sulfur. So to begin with, of course, its melting point is in the range of 393 Kelvin. You can just see, whereas the rhombic sulfur was nearly 35.8 Kelvin, whereas that of your monoclinic is nearly very high, which is of the range of 393 Kelvin. Of course, it is also soluble in that of your CS2 solvent, that is your carbon disulfide. But when the question arises that how to prepare this monoclinic sulfur, the general tendency which we say is, the general preparation, they are mainly obtained by melting the rhombic sulfur. Okay, so ಏನ್ ನಮ್ದು ನಮ್ಮ ರೋಂಬಿಕ್ ಸಲ್ಫರ್ ಇರುತ್ತೆ ಅದನ್ನ ನಾವು ಮೆಲ್ಟ್ ಮಾಡಿದ್ರೆ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ which I am going to say it. ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ ಬರೋದು ಯಾವ್ದಾಗಿರುತ್ತೆ, ಯೋರ್ ಮೊನೋಕ್ಲಿನಿಕ್ ಸಲ್ಫರ್. ಕಮಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಇಟ್ಸ್ ಸ್ಟೆಬಿಲಿಟಿ, ಓಕೆ, ಯಾವ ಟೆಂಪರೇಚರ್ ರೇಂಜ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಈ ರೋಂಬಿಕ್ ಸಲ್ಫರ್ ಅಥವಾ ಮೊನೋಕ್ಲಿನಿಕ್ ಸಲ್ಫರ್ ಸ್ಟೇಬಲ್ ಅಂದ್ರೆ, ರಿಮೆಂಬರ್ when you talk about the monoclinic sulfur, it is nearly stable above 369 ಕೆಲ್ವಿನ್. ಏನ್ ಹೇಳ್ತೀವಿ ನಾವು, ಅಫ್ಕೋರ್ಸ್ ಈ ಮೊನೋಕ್ಲಿನಿಕ್ ಸಲ್ಫರ್ ಏನಾಗಿರುತ್ತೆ, ಯಾವುದೇ ಒಂದು ನಾವು ಎಲಿಮೆಂಟ್ ತಗೊಂಡು ಅದು ಸ್ಟೆಬಿಲಿಟಿ ನಾವು ನೋಡ್ಲೇಬೇಕು. ಸೊ ಅದು ಯಾವಾಗ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ, ವೆನ್ ಎವರ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಟೆಂಪರೇಚರ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ಯೋರ್ 369 ಕೆಲ್ವಿನ್. ಒಂದ್ ವೇಳೆ ನಾವು 369 ಗಿಂತ ಕಡಿಮೆ ಇಟ್ಟಿವಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಬೇಸಿಕಲಿ ನಿಮ್ದೇನು ಮೊನೋಕ್ಲಿನಿಕ್ ಸಲ್ಫರ್ ಇರುತ್ತೆ, ಇಟ್ ಜನರಲಿ ಗೆಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಸ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ ಆಲ್ಫಾ ಸಲ್ಫರ್. ಯಾವಾಗ when the temperature is less than 369 Kelvin. ಯಾವಾಗ 369 Kelvin ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಮೊನೋಕ್ಲಿನಿಕ್ will remain as such. But once the temperature is reduced below 369 Kelvin, what happens? It is forming an alpha sulfur. Same is the case with respect to your alpha sulfur also. Your alpha sulfur is stable. Can anybody say what will be the temperature range? Yes. Your alpha sulfur is stable at nearly less than 369 Kelvin. ಏನಾಗಿರ್ಬೇಕು, ಕಮ್ಮಿ 369 ಕೆಲ್ವಿನ್ ಗಿಂತನೂ ಕಡಿಮೆ ಇರಬೇಕು. ಎಲ್ಲಾದ್ರೂ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, once again your alpha sulfur get transforms to that of your beta sulfur. So if you can make a note over here, what is that? Again and again we are giving a temperature range of what, 369. ಇಲ್ಲ above ಇರಬೇಕು, ಇಲ್ಲ below ಇರಬೇಕು. ಅದೇ ಒಂದು ಕ್ವಶನ್ ಜನರಲ್ ಆಗಿ ನಮ್ಗೆ ಅರೈಸ್ ಆಗೋರುತ್ತೆ. at 369 ಅಲ್ಲಿ ಏನಾಗಬಹುದು, ಕರೆಕ್ಟ್ 369 ಅಲ್ಲಿ ಇಟ್ಬಿಟ್ರೆ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ರಿಮೆಂಬರ್ ಬೋತ್ ದಿ ಫಾರ್ಮ್ಸ್ ಆಫ್ ದಿ ಅಲೋಟ್ರೋಪ್, ಓಕೆ, ಬೋತ್ ದಿ ಫಾರ್ಮ್ಸ್ ಆಫ್ ಸಲ್ಫರ್ ಆರ್ ಸ್ಟೇಬಲ್. ಈ ಟೆಂಪರೇಚರ್ ರೇಂಜ್ ನೇ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್. ದಿಸ್ ಟೆಂಪರೇಚರ್ ರೇಂಜ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್. ಇಟ್ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಫಾರ್ ಅ 1 marker. What do you mean by a transition temperature? Remember, in P block, the transition temperature refers to what? It's a temperature range at which both the allotropes of the sulfur are stable, and the range also you have to write, that is your 369 Kelvin. Is it clear? So these were the certain important properties of that of your rhombic sulfur and that of your monoclinic sulfur. Of course, when I am dealing with the allotropes, the important question which arises in our mind is about their ಸ್ಟ್ರಕ್ಚರ್. ಯಾವ ತರ ಸ್ಟ್ರಕ್ಚರ್ ಇರುತ್ತೆ ಅನ್ನೋದು ಬೇಕಲ್ವಾ. ಈಗ ನಾವು ಗ್ರಾಫೈಟ್ ಇಸ್ ಅಲೋಟ್ರೋಪ್ ಆಫ್ ಅ ಕಾರ್ಬನ್ ಅಂತ ಹೇಳ್ಕೊಳ್ಳಿ, ನಾವೇನ್ ಹೇಳ್ತೀವಿ, ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಹೆಕ್ಸಾಗೋನಲ್ ಶೇಪ್ ಅಲ್ವಾ. ಡಿಫ್ರೆಂಟ್ ಹೆಕ್ಸಾಗೋನಲ್ ಲೇಯರ್ಸ್ ಇರುತ್ತೆ, ಪ್ರತಿ ಒಂದು ಶೀಟ್ ಏನಾಗಿರುತ್ತೆ, ವ್ಯಾನ್ ಡರ್ ವಾಲ್ಸ್ ಫೋರ್ಸ್ ಇಂದ ಜೋಡಣೆ ಆಗಿರುತ್ತೆ. ಅದೇ ರೀತಿ ವೆನ್ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿ ಅಲೋಟ್ರೋಪ್ಸ್ ಆಫ್ ದಿ ಸಲ್ಫರ್, ರಿಮೆಂಬರ್ ದಿಸ್ ಅಲೋಟ್ರೋಪ್ಸ್ ಆಫ್ ದಿ ಸಲ್ಫರ್ ಬೋತ್ ರೋಂಬಿಕ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಮೊನೋಕ್ಲಿನಿಕ್, ಅವೆರಡು ಯಾವ ಸ್ಟ್ರಕ್ಚರ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂದ್ರೆ S8 ಮಾಲಿಕ್ಯೂಲ್ ರೀತಿಲಿ ಇರುತ್ತೆ. ಓಕೆ, S8 molecules. Okay, they will be having an S8 molecules. This S8 molecules, individually S8 molecules, they are packed in such a way to give a different crystals. ಬೇರೆ ಬೇರೆ ರೀತಿ crystals ಕೊಡ್ತಾ ಹೋಗುತ್ತೆ. So when I'm very much particular about my S8 form of my rhombic sulfur, basically it is having a crown shape ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವ ಶೇಪು? Crown shape. Very much important. Just see the shape of it. Crown shape ಅಲ್ಲಿ ಇರುತ್ತೆ. ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ, it will be in this format like this. So here comes your part once again. ಎಲ್ಲಿ ಸರ್ SA2? Basically here 1 sulfur, 2 sulfur, 3 sulfur, 4, 5, 6, 7 and 8. That is the reason I said ಇದು ಒಂದು ಪಾರ್ಟ್. ಈ ತರ ಏನಾಗಿರುತ್ತೆ, ಹಲವಾರು ಒಂದು S8 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಪ್ಯಾಕ್ ಆಗಿರುತ್ತೆ, ಒಂದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಕೊಡೋಕೆ. ಸೊ ದಿಸ್ ವಾಸ್ ಯುವರ್ S8 ಫಾರ್ಮ್. ಸೊ ರೋಂಬಿಕ್ ಸಲ್ಫರ್ ಬರೀ S8 ರೀತಿಲೇ ಇರೋದಿಲ್ಲ, ಈವನ್ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ಅನ್ S6 ಫಾರ್ಮ್ಯಾಟ್. S6 ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಕೂಡ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ವೆನ್ ಎವರ್ ಇಟ್ ಇಸ್ ಇನ್ ದಿ S6 ಫಾರ್ಮ್ಯಾಟ್, ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಚೇರ್ ಫಾರ್ಮ್. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. S8 ಅಲ್ಲಿ ಇದ್ದಾಗ ಕ್ರೌನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, S6 ಅಲ್ಲಿ ಇದ್ದಾಗ ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಚೇರ್ ಫಾರ್ಮ್. ಚೇರ್ ಫಾರ್ಮ್ ನೋಡಿ, ಇಟ್ ಇಸ್ ಇನ್ ದಿಸ್ ವೇ. Just see how I am writing so that it would be easy for you to also write. So this is your 1 sulfur, 2, 3, 4, 5 and 6. So whenever your rhombic sulfur is existing in the S8 format, it will be having a crown shape, whereas whenever it is complete coming in the form of your S6, it will be having a chair form. Is it clear? So these were some important aspects of your sulfurs and their importance of the allotropes. So guys, when we were dealing with the allotropes of the sulfur, you can get a doubt over there. What is the doubt? So why we are calling rhombic sulfur as that of your alpha sulfur? Why we are calling your rhombic sulfur as that of your alpha sulfur, and why that of your monoclinic is called as that of your beta sulfur? The answer is simple. It is nothing to deal with its structure. The answer is what means in Greek letters, basically alpha means A. Okay, means first alphabet. Okay, first alphabet. So when we are talking about the allotropes of the sulfur, the main important allotropes, of course, the first comes the rhombic and then comes your monoclinic. Why is it so? So generally, whenever we are talking about the temperature range, as I have mentioned, below 369 ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು ನಿಮ್ಮ rhombic sulfur exist ಆಗುತ್ತೆ. Greater 369 ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಿಮ್ಮ monoclinic sulfur exist ಆಗ್ತಾ ಉಂಟು. ಹಾಗಾದ್ರೆ ಫಸ್ಟ್ ಯಾವ್ದು ಬರ್ತಾ ಉಂಟು allotropes of the sulfur ಅಲ್ಲಿ? monoclinic. ಸೊ ಆತರ ಫಸ್ಟ್ ಯಾವ್ದು ಬರ್ತಾ ಉಂಟು ನಿಮ್ದು rhombic sulfur. ಸೊ ಆತರ ಒಂದು ಪ್ರೆಫರೆನ್ಸ್ ನ ತಗೊಂಡು ನಾವು ಗ್ರೀಕ್ ಲೆಟರ್ಸ್ ಮೂಲಕ ಅದನ್ನ ಏನ್ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೇವೆ as that of your alpha sulfur. So soon after the rhombic, the next comes is your monoclinic. Alwa, soon after that one it comes your monoclinic sulfur. So here what alpha adal bara next letter yadu beta. So that is the reason monoclinic is called as that of your beta sulfur. Are you getting my point? Since rhombic sulfur comes first, it is called as that of your alpha sulfur. Then comes your which one monoclinic, it is called as that of your beta sulfur. So guys, now let us see the first compound of a sulfur, that is your sulfur dioxide. Sulfur dioxide. Coming with respect to its preparation part, how to prepare it. The most common preparation of a sulfur dioxide is by burning the sulfur in the presence of oxygen. Sulfur na oxygen jothe burn madre saku nimatra barade nima SO2 gas. Here whatever the sulfur you will be taking will be in the solid state, whereas of course O2 will be in the gaseous state. But one of the main disadvantage ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಈ ಒಂದು process ಅಲ್ಲಿ along with the SO2 part, you will be also obtaining nearly 6 to 8% of your sulfur trioxide. Of course, which is not a much part, but of course there is an additional product we are going to obtain. So even the process ಅಲ್ಲಿ ಇದೆ main disadvantage. Coming with respect to the laboratory part, lab ಅಲ್ಲಿ ನಾವು ಯಾವ ತರ ಇದನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ laboratoryಲಿ, basically SO2 is prepared by treating your sulfite. Okay, by treating your sulfite ಅಂದ್ರೆ ಯಾವ ತರ ಫಾರ್ಮ್ಯಾಟ್ ಇರುತ್ತೆ SO3 minus 2. I'll just write my ionic reaction. So whenever you're treating your sulfite with dilute sulphuric acid, basically you will be getting your sulfur dioxide gas, along with that one as a byproduct your water vapors. Are you getting my point? So laboratory ನಾವು ಯಾವ ತರ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ by treating your sulfite part. Any sulfites you can take with that of your dilute sulphuric acid. Dilute sulphuric acid ಅಲ್ಲಿ ನಮಗೆ important component ಯಾವುದಲ್ಲಿ the proton, which is going to give you as an SO2, that is the sulfur dioxide, along with that one that of your water. Coming with respect to the industrial preparation, okay, basically industries, as I have mentioned, always they think about their profit. So basically ನಾವು ಇಂಡಸ್ಟ್ರಿಯಲ್ಲಿ SO2 ನ ಯಾವ ತರ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ this SO2 ನಮಗೆ ಬೈ ಪ್ರಾಡಕ್ಟ್ ರೀತಿಯಲ್ಲಿ ಬರ್ತಾ ಉಂಟು. ಯಾವ ತರ? by the roasting of your sulfide ores. ಈಗ ನಾವು ನಮ್ಮ ಜನರಲ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅಂಡ್ ಐಸೋಲೇಷನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. ಯಾವುದೇ ಒಂದು ಓರ್ ಇಂದ ಮಿನರಲ್ ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಸುಮಾರು ಪ್ರೊಸೆಸ್ ಗಳನ್ನ ಮಾಡ್ಬೇಕು. ಸೊ ಅದೇ ರೀತಿ ಸಲ್ಫೈಡ್ ಓರ್ಸ್ ಬಂದಾಗ ನಾವ್ ಏನ್ ಮಾಡ್ತೀವಿ, ವಿ ವಿಲ್ ರೋಸ್ಟ್ ಇಟ್ ಅಲ್ವಾ. ಸೊ ರೋಸ್ಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಒನ್ಸ್ ಸಲ್ಫೈಡ್ ಓವರ್, ಲೆಟ್ ಮಿ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್, FeS2. ಓಕೆ, ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ರೋಸ್ಟೆಡ್ ಮೀನ್ಸ್ ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಆಕ್ಸಿಜನ್, ಅಫ್ಕೋರ್ಸ್ ನಮಗೆ ನಮ್ಮ Fe2O3 ಬಂತು, ಆದ್ರೆ ಇದ್ರ ಜೊತೆ ಒಂದು ಬೈ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, ಏನು SO2. ಅಫ್ಕೋರ್ಸ್ ಈ SO2 ಏನೋ ನಮಗೆ ನೆಸೆಸಿಟಿ ಇರ್ಲಿಲ್ಲ, ಯಾರಿಗೆ, ನಮಗೆ. ಆದ್ರೆ ಇಂಡಸ್ಟ್ರೀಸ್ ಆತರ ಯೋಚನೆ ಮಾಡಲ್ಲ. ಅವಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ, ಏನೇ ಒಂದು ಬೈ ಪ್ರಾಡಕ್ಟ್ ಬಂದ್ರೆ ಅದು ಫರ್ದರ್ ಯೂಸ್ ನ ನೋಡ್ತಾರೆ. ಸೊ ಈ ಗ್ಯಾಸ್ ಏನ್ ಆಕ್ಚುಲಿ ದಿಸ್ ವಾಸ್ ಅವರ್ ಮೇನ್ ಕಾಂಪೋನೆಂಟ್. ಓಕೆ, ದಿಸ್ ವಾಸ್ ದಿ ಮೇನ್ ಕಾಂಪೋನೆಂಟ್. ಐರನ್ ಆಕ್ಸೈಡ್ ಓರ್ ಐರನ್ ಆಕ್ಸೈಡ್ ಏನ್ ಸಿಕ್ಕಿದ್ರು, ದಿಸ್ ಇಸ್ ದ ಮೇನ್ ಕಾಂಪೋನೆಂಟ್ ಪಾರ್ಟ್. ಇದನ್ನ ಅವ್ರಿಗೆ ಏನ್ ಮಾಡ್ತಿದ್ದಾರೆ, SO2 ಬಂದಿದ್ದ ಅದನ್ನ ಹಾಗೆ ಅವ್ರು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತಾರೆ. ಏನ್ ಮಾಡ್ತಾರೆ, ಈ SO2 ಗ್ಯಾಸ್ ನ ಪ್ರೆಷರೈಸ್ಡ್ ಮಾಡಿ, ಓಕೆ, ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೆಷರೈಸ್ಡ್ ಇಟ್, ಓಕೆ, ಆಫ್ಟರ್ ಡ್ರೈಯಿಂಗ್ ಪ್ರೆಷರೈಸ್ಡ್ ಮಾಡಿ ಅದನ್ನ ಲಿಕ್ವಿಡ್ ಫಾರ್ಮ್ ಗೆ ತಗೊಬಂದ್ಬಿಡ್ತಾರೆ. ಓಕೆ, ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲಿಕ್ವಿಫೈ ದಟ್ ಗ್ಯಾಸ್ and then they are going to store it in the steel cylinders. then they store it in the steel cylinders. Are you getting my point? So ಒಂದೇ ಮೆಥಡ್ ಅಥವಾ ಒಂದೇ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಅಫ್ಕೋರ್ಸ್ ದೇ ಆರ್ ಆಲ್ಸೋ ಏನ್ ಮಾಡ್ತಿದ್ದಾರೆ, ದೇ ಆರ್ ಕಾನ್ಸಂಟ್ರೇಟಿಂಗ್ ದಿ ಓರ್ ಅಲಾಂಗ್ ವಿತ್ ದಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಓರ್, ದೇ ಆರ್ ಆಲ್ಸೋ what you can say producing that of your SO2 which is kept in that of your steel cylinders after pressurizing it. So these were the three important preparations of your SO2. First of all, by burning sulfur directly in the presence of oxygen. Okay, in the laboratory by treating your sulfite with that of your dilute sulphuric acid, and in the industries by the roasting of your sulfidos. So coming with respect to its properties, coming with respect to the properties of your SO2, okay, very much important. I would be mainly dealing with some important properties which will be involving certain important reactions. So first important property we are going to study is what happens when your SO2 is reacting with that of your water. Of course, what happens, what you can think, any idea? So remember, whenever SO2 is going to react with water, okay, it is going to give you as a sulfurous acid, H2SO3. Just remember the name, what it is giving, sulfurous acid. Sulfurous acid. Are you getting my point? H2SO3, not sulphuric. Sulphuric andre enagadu H2SO4. This is a component which we are having as O3, H2SO3, which is called as what? Sulfurous acid. Okay. Similarly, this was the case when it is reacting with the water. Even your SO2 reacts with NaOH. So when your SO2 is going to react with that of your NaOH, basically it first gives you as a sodium sulfite, Na2SO thrice, along with that of your water. If you're going to balance this, you'll be getting as a 2NaOH. But the reaction doesn't stop over here. Whatever the formed sodium sulfite was there, Na2SO3, it once again reacts with your SO2 in the presence of water to give you the final product as that of your sodium bisulfite, NaHSO thrice. Now the reaction stopped. So yavagli agli SO2 when it is reacting with NaOH, don't stop the reaction as sodium sulfite. Remember, once again that sodium sulfite is going to react with that of your SO2 to give that of your sodium bisulfite. Coming to the third important property, okay, what happens when SO2 reacts with the chlorine? Okay, basically whenever the SO2 is reacting with the chlorine, it will be requiring a catalyst. Basically we use the charcoal as a catalyst. So whenever your SO2, that is your sulfur dioxide, is reacting with the chlorine, it is going to give you as a sulfuryl chloride, that is SO2Cl2. So this is called as what? Sulfuryl chloride. Guys, why I am going to signifying these properties? Because it is important both in the point of your exams and also in the point of your competitive. Okay, they can ask you directly what, give complete the reaction anta kotti, reactant na kotti, they can ask you the product part. That is the reason I am mainly focusing on the reactions of the in the properties. So when SO2 is reacting with water, it is giving you the sulfurous acid. When SO2 is reacting with NaOH, first it gives you as a sodium sulfite. Very much important. It is sodium sulfite, Sulphite. Okay. Similarly, that sodium sulfite doesn't stop over there. It once again reacts with the SO2 to give the final product as that of your sodium bisulfite. Whereas that of your sulfur dioxide reacts with the chlorine to give that of your sulfuryl chloride. Of course, this sulfur dioxide, okay, SO2, it is also oxidized to that of your SO3. Andre, whenever your SO2 is going to react with that of your oxygen in the presence of your vanadium pentoxide catalyst, okay, we require a vanadium pentoxide catalyst where vanadium is in the +5 oxidation state. Of course, this is an oxidation reaction, so your SO2 gets oxidized to that of your SO thrice. SO2 na yen martivi navu SO thrice ige convert martivi. Very much important part this reaction. Why? Because this is the important reaction in that of your contact process. Even though reaction is a very much important reaction, because in contact process, in the manufacture of sulfuric acid, okay, this is the main role which will be played by the reaction in the synthesis of your sulfuric acid, which will be seen once again in your manufacture of H2SO4. But do remember, whenever your sulfur dioxide is reacting with the oxygen in the presence of vanadium pentoxide, it will get oxidized to give you as a sulfur trioxide. Coming to the most important property, remember your SO2 acts as a reducing agent. SO2 acts as a reducing agent. We'll see certain two important reactions where SO2 reacts as that of your reducing agent. So remember, whenever you're going to treat your Fe3 plus in the presence of SO2 and that of your water, your Fe3 plus is reduced to that of your Fe2 plus, SO4 2 minus plus that of your H plus. In case if I want to balance this, yes, 2 Fe3 plus, here also 2 Fe2 plus. Coming with respect to sulfur, sulfur is balanced. What about your hydrogen? Yes, 2H2O. Here I can put as 4H plus. Now I think oxygen is also balanced. So yake ನಾವು reducing agent ಅಂತ ಹೇಳ್ತೀವಿ SO2 ನ. You can just see that Fe3 plus ಇದಿದೆ ಏನಾಗಿದೆ Fe2 plus ಆಗಿದೆ. That is gaining of one electron. So whenever a electron has been gained, ನಾವು ಅದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ reduction ಅಂತ ಹೇಳ್ತೀವಿ. So this was the possible when in the presence of your SO2. Not only this much, even when you treat your permanganate, potassium permanganate with that of your SO2 in the presence of water, it is going to give you what? Yes, it is first of all, it gives you as a Mn2 plus that of your SO4 2 minus plus that of your H plus. You can ask me. So it really reduce agide. Basically, when you check out the oxidation state of the Mn, it is in +7 state. Alva? Nodi bekare X, idu MnO4 minus alva, X minus 8 is equals to -1, X is equals to -1 plus 8, which is equals to +7, where +7 idu +2 ಆಗ್ತಾ ಉಂಟು. 5 electrons has been gained. 5 electrons has been gained. So whenever there is a gaining tendency, of course, it's a reduction process. So that is the reason we say that your SO2 acts as one of the best reducing agent. In order to balance this, 2 MnO4 minus, yes, so 2 MnO4 minus and the 2 Mn2 plus. What about your oxygen? 4 2s are 8 plus 2 10 barutte. Illestuntu SO4 alva. So I can write it as a 5 SO4 2 minus 5 SO4 2 minus andre 4 2s are 8 9 10. Here 5 4s are I got as a 20. Oh, so I can use here as a 2H2O and over as a 5 SO2. So 5 SO4 2 minus. So now balance your hydrogen. 2 2s are 4 H plus 4H plus. Balancing is nothing. ನಿಮ್ಮ right hand side ಎಷ್ಟಿರುತ್ತೆ ಅಷ್ಟೇ number of the atoms ನಿಮ್ಮ left hand side ಕೂಡ ಇರಬೇಕು. Okay, so these are the important properties of your sulfur, which we came to know that whenever your sulfur dioxide is going to react with the water, it is going to give you the sulphurous acid. So when it is reacting with the NaOH, it is giving you the sodium sulfide, which once again reacts with that of your SO2 to give that of your sodium bisulfide. Similar is the case when your sulfur dioxide reacts with the chlorine in the presence of a charcoal, it is going to give us that of your sulfuryl chloride. Coming with respect to the reaction of the sulfur dioxide with oxygen, it gives you as that of your sulfur trioxide. Similarly, the most important part is that of your SO2 is acting as a reducing agent, which is the proof which is shown in the following reaction, where your Fe3 plus has been reduced to Fe2 plus in the presence of SO2. Similarly, your Mn plus 7 has been reduced to Mn plus 2. Mn plus 7 ididu Mn plus 2 agide. Okay, which has been reduced, which indicates in the presence of that of your SO2, indicating that your sulfur dioxide acts as an reducing agent. Okay. So guys, the next important topic we are going to check out in sulfur is your oxo acids of sulfur. Oxo acids of sulfur. So as we have seen the oxo acids of the phosphorus, here also we will be seeing certain important structures. Oxo acids andre adu where you will be having the oxygen, hydrogen and that of the respective element, that is in this case it will be sulfur. So basically we are going to see the 4 important oxo acids of sulfur. One is that of your H2SO4, just the structures we are going to see. H2SO4, then that of your H2SO thrice, that is your ಯಾವುದು ಹೇಳಿದೆ ಇದು sulphurous acid. Then we are going to see as that of your H2S2O8, which is called as a peroxo disulphuric acid. Then we are going to see the H2S2O7. So all these structures will be studied now one by one. So first of all, let me go with my sulphurous acid. That is my H2SO thrice, which is called as what? Sulphurous acid. Okay. So first of all, the structure is in this way. So you will be having a sulfur with a 2 lone pair of electrons with OH and a OH and a double bond O. Alva? So you just see H2SO3. Okay, H2SO3, but do remember it is having one lone pair of electrons. Coming to the next part is your H2SO4, which means sulphuric acid, which is your sulphuric acid. So in this case, you are having as an S, double bond O, and here you are having as an OH and an OH. You can just see ಇಲ್ಲಿ ಏನು ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇತ್ತು ಆ ಜಾಗದಲ್ಲಿ ಏನಾಗಿದೆ ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಓ ಬಂದಿದೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ ಜಸ್ಟ್ ಕೌಂಟ್ H2SO4 1 2 3 4. Okay, coming with respect to the next part, as I said, H2S2O8, which is called as what? Peroxo disulfuric acid. Peroxo disulfuric acid. So which is indicating what? In this structure you will be having the two sulfurs. You just see how they are bonded. So S O ಹೋಗಿದೆ, ಆ ಇನ್ನೊಂದು O ಇನ್ನೊಂದು O ಹೋಗಿ ಆ O ಮೂಲಕ ಇನ್ನೊಂದು S ಗೆ ಜಾಯಿನ್ ಆಗಿದೆ. This is first case. Then as usual, double bond O it is having, and one OH. The same scenario over here, double bond O and an OH. Are you getting my point? So this is your H2S2O8. The next important oxo acids we are going to see of the sulfur is your oleum. Is tumbane important. Okay, oleum. Why I am saying it is important? Because this is also the one of the important product in the manufacture of your sulfuric acid. So ee product ಬಂದ್ಮೇಲೆನೆ ನಾವು ಲಾಸ್ಟ್ ಪ್ರೊಸೆಸ್ ಗೆ ಹೋಗ್ತೀವಿ. ಏನಾದ್ರೂ ಹೆಸರು oleum. Okay, just see the formula H2S2O7. ಸೊ ಈಗ ಏನಾಗುತ್ತೆ S ಡಬಲ್ ಬಾಂಡ್ ಇಲ್ಲಿ ಏನಾಗಿತ್ತು ನೋಡಿ O8 ಅಂತ ಇತ್ತು. ಸೊ ಆ ರೀಸನ್ ಇಂದ ನಮಗೆ ಎಲ್ಲ ಟೋಟಲ್ ಆಗಿ 8 ಬಂದು ಇಲ್ಲೇನಾಗಿದೆ ರೆಸ್ಟ್ ಆಲ್ ಇಸ್ ಸೇಮ್, ಒಂದು ಆಕ್ಸಿಜನ್ ಕಡಿಮೆ ಉಂಟು. ಹಾಗಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಒಂದು ಆಕ್ಸಿಜನ್ ಇದರಲ್ಲಿ ಎಲಿಮಿನೇಟ್ ಮಾಡಬೇಕು. ಸೊ S double bond O, here you are having as a OH, here you will be having as a O. As usual, the remaining structure is as it is, double bond O and an OH. So this is the only part we have to understand with respect to the oxo acids of the sulfur. Some important structures. One is first was your sulfurous acid, where you will be seeing that your sulfur is having one lone pair of electron with a double bond O and two OH bonds. Whereas that of your sulfuric acid, you are having a two double bond O's and that of your two OH bonds. Coming with respect to your peroxo disulfuric acid, you are having as a two double bond O, okay, in one part, or in total case if I want to say totally four double bonds O, two OH and two bridged oxygens. Yes, coming with respect to that of your oleum, you are having just one bridging oxygen and that of your four double bonds O and that of your two double bond OH. Is that clear? This is the only topic of that of your oxo acids of sulfur. Only this much has been included as per your syllabus. So the next important part we are going to study in the sulfur is that of your sulfuric acid. Sulfuric acid. So pay attention over here. Very important topic. So ಯಾವಾಗ ನಾವು sulfuric acid ಅಂತ ಕಲಿತೀವಿ, the first important point which strikes our mind is a process name called as that of your contact process. Contact process. So basically this is a process name in which you are going to see how to manufacture your sulfuric acid. So whenever we talk about your contact process, okay, the manufacture of sulfuric acid, mainly there involves 3 steps. Okay, it's a 3-step process. So first step involves what? Is the burning of sulfur, okay, or that of your sulfide ores. Okay, your sulfide ores in the presence of air. The only reason is to generate that of your sulfur dioxide. So first process ಏನಾಗಿರುತ್ತೆ ನಿಮ್ಮ ಕಾಂಟ್ಯಾಕ್ಟ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಸಲ್ಫರ್ ಅಥವಾ ಸಲ್ಫೈಡ್ ಓರ್ಸ್ ನ ಆಕ್ಸಿಜನ್ ಮೂಲಕ ಬರ್ನ್ ಮಾಡ್ತೀವಿ. ಬರ್ನ್ ಮಾಡಿದಾಗ ನಮ್ಗೆ ಅಫ್ಕೋರ್ಸ್ ನಾವು ನೋಡಿದ್ವಿ ರಿಯಾಕ್ಷನ್ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ರಿಯಾಕ್ಷನ್ ನಮಗೆ ಏನ್ ಬರುತ್ತೆ, SO2 ಬರುತ್ತೆ. ಇದು ನಿಮ್ಮ ಫಸ್ಟ್ ಪ್ರೊಸೆಸ್, ಓಕೆ, ಇನ್ ದಿ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ದಟ್ ಆಫ್ ಯೋರ್ sulfuric acid. And rule, okay, coming with respect to the second part, which is one of the key reaction or key step antane helbodu. Okay, it is the conversion of, or we can sample words, we can say that oxidation of SO2 to SO3. SO2 to SO3 ಇದು ಹೇಗೆ ಬರುತ್ತೆ ನಮಗೆ by the reaction with oxygen in the presence of vanadium pentoxide catalyst, in the presence of V2O5 catalyst. So by utilizing vanadium pentoxide catalyst, we will be converting your sulfur dioxide to that of your sulfur trioxide. Okay, will be your second reaction. The third important reaction is that whatever the SO3 has been obtained, it has been undergoing an absorption. Okay, absorb agutte yadru mulaka in H2SO4, to give oleum. The same oleum which we saw in that of your oxo acids of sulfur, H2S2O7. So these are the three important steps which are involved in that of your contact process. First of all is the conversion of your sulfur or a sulfide ores to that of your sulfur dioxide by burning them in the presence of oxygen. Then comes is your catalytic oxidation of your sulfur dioxide to that of your sulfur trioxide. And the last part involves the absorption of sulfur trioxide in H2SO4 to give that of your oleum. Okay, so whenever we are dealing with any process, any industrial process, always there is a need to understand the conditions, okay, to see the conditions which results in the maximum yield of our product. So similar is the case with respect to that of your contact process. What are those conditions? First of all, you have to maintain a temperature in the range of nearly 720 Kelvin. Okay, 720 Kelvin ali ನಿಮ್ಮ ಒಂದು process na ನೀವು start ಮಾಡಬೇಕು. Similarly, you have to keep the pressure to that of your 2 bar atmospheric pressure na ನಾವು maintain ಮಾಡಿರ್ತೀವಿ. So these are the two important parts in which you have to maintain the conditions in the case of your contact process to get the maximum yield of your sulfuric acid. Now coming with respect to certain reactions, what are the reactions which are carried out in that of your contact process? Do remember, as I mentioned, first of all, the key reaction which is very, very important in the manufacture of your sulfuric acid is the catalytic oxidation of your SO2, to SO3 or SO3 in the presence of V2O5 as a catalyst. V2O5. So ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ SO2 ನ ನೀವು ಆಕ್ಸಿಜನ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡ್ತೀರಾ. This reaction is carried out in the presence of vanadium pentoxide to get as that of your SO3. When you balance this, you will be getting as a 2SO2. Okay, so 2 2s are 4, 5, 6. So here you can be writing as what? 2SO thrice. But the general part, ಯಾಕೆ ಸರ್ ನಾವು ಇದೇ ಟೆಂಪರೇಚರ್ ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀವಿ, ಇದೇ ಪ್ರೆಷರ್ ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದ್ರೆ you will understand with this part. So when you just see the enthalpy of formation over here, it will be having a minus 196.6 kilojoules per mole. 196.6 kilojoules per mole. Keeping the numbers aside, noticing the sign, we are understanding that it is an exothermic reaction. What it is? It is an exothermic reaction. Remember, whatever the catalytic oxidation you are seeing over here, it's a reversible reaction. Okay, it is a reversible reaction. Applying the Lee-Chatelet principle, ಒಂದು ವೇಳೆ ನೀವೆಲ್ಲರೂ ಟೆಂಪರೇಚರ್ ನ ಜಾಸ್ತಿ ಮಾಡ್ತೀರಾ ಅಂದಾಗ ಏನಾಗುತ್ತೆ, ಇವೆಲ್ಲ ಗ್ಯಾಸ್. ಸೊ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಟೆಂಪರೇಚರ್ ನ ನಲ್ಲಿಫೈ ಮಾಡಕ್ ನೋಡುತ್ತೆ. ಸೊ ನಲ್ಲಿಫೈ ಮಾಡ್ಬೇಕಂದ್ರೆ ಅರ್ಥ ಏನು, ಎಂಡೋಥರ್ಮಿಕ್ ಆಗ್ಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ರಿಯಾಕ್ಷನ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಆಗಿ ಹೋಗ್ಬಿಡುತ್ತೆ. ಸೊ ಬ್ಯಾಕ್ವರ್ಡ್ ಆಗಿ ಹೋದಾಗ ಏನಾಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ SO3 ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, yield of the sulfuric acid ಕೂಡ decrease ಆಗುತ್ತೆ. So ಆ reason ಇಂದನೇ whenever you are doing your contact process, we generally prefer your low temperature. Okay, that is the reason we are maintaining a low temperature. But along with that one, we will be mentioning a very high pressure. Okay, high pressure ನ maintain ಮಾಡ್ತೀವಿ. ಯಾಕೆ high pressure? ಈಗ ಒಂದು ವೇಳೆ ನೀವು ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಮಾಡ್ತಿದ್ರೆ ರಿಯಾಕ್ಷನ್ ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಇನ್ ದಿ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಲೋ ಟೆಂಪರೇಚರ್ ಇದ್ದಾಗಲೂ ಯಾವ ಕಡೆ ರಿಯಾಕ್ಷನ್ ಹೋಗುತ್ತೆ, with respect to that of your forward direction. So our reason indane, to get the maximum yield of the sulfuric acid in this catalytic oxidation, we will be maintaining a very low temperature and that of your high pressure. Okay, but do remember, low temperature we can't keep very, very low. ಸೊ ಆತರ ನೀವು ಲೋ ಟೆಂಪರೇಚರ್ ನ ಮೇಂಟೈನ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ದ ರೇಟ್ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್ ಬಿಕಮ್ಸ್ ವೆರಿ ಸ್ಲೋ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೆಂಪರೇಚರ್, ದಟ್ ಇಸ್ 720 Kelvin is a preferable temperature to get the maximum yield of your sulphuric acid. So once you have carried out the catalytic oxidation of SO2 to SO3, the second important key reaction is conversion of your SO3 to oleum. ಸೊ ಅದನ್ನ ಯಾವ ತರ ಮಾಡ್ತಾರೆ, ವಾಟ್ ಎವರ್ ದಿ SO3 is been produced ಅಲ್ಲ, ಅದನ್ನ ಏನ್ ಮಾಡ್ತಾರೆ, H2SO4 ಮೂಲಕ ಅದನ್ನ ಪಾಸ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್, ಏನ್ ಮಾಡ್ತೀವಿ, SO3 ನ H2SO4 ಅಲ್ಲಿ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂತೀವಿ. ಅವಾಗ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಿಮ್ಮ ರಿಯಾಕ್ಷನ್ ಏನಾಗುತ್ತೆ, H2S2O7, H2S2 and O7 completely balanced, no need of balancing. So once you have obtained the oleum, okay, oleum ಒಂದ್ಸರಿ obtain ಆದ್ಮೇಲೆ ಈ oleum ಏನಿರುತ್ತಲ್ಲ H2S2O7 ಇದನ್ನ ನಮ್ಮ ಡಿಸೈರ್ಡ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ವಾಟರ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿ ನಮ್ಗೆ ನಮ್ಮ H2SO4 ಸಿಗುತ್ತೆ. ಸೊ ಬೇಸಿಕಲಿ ಇಲ್ಲಿ ನಾನು ಒಂದು ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದೆ, ಏನದು, ಡಿಸೈರ್ಡ್ ಕ್ವಾಂಟಿಟಿ. ಸೊ ನಿಮಗೆ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬೇಕು ಅದನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ, ಈ ಓಲಿಯಂ ನ ಎಷ್ಟು ನಮಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬೇಕು ಅಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡ್ಕೊಂತೀವಿ, ಅಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ನ ಗೇನ್ ಮಾಡ್ಕೊಂತೀವಿ. ಡೂ ರಿಮೆಂಬರ್ ಈ ಒಂದು ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ನೀವೆಲ್ಲಾದ್ರೂ ಬಂದಿರೋ ಅಷ್ಟು ಓಲಿಯಂ ನ ಯಾವುದೋ ಒಂದು ಸ್ಪೆಸಿಫಿಕ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಿಯರ್ಲಿ ನಿಮ್ಗೆ 96 to 98% ಆಫ್ ದಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಸಿಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಆ ರೀಸನ್ ಇಂದಾನೆ ನಾವು ಹೇಳೋದು ನಮ್ಗೆ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬೇಕು ಅಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಓಲಿಯಂ ನ ವಾಟರ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿ ಫೈನಲ್ ಆಗಿ ನಮ್ಗೆ ನಮ್ಮ H2SO4 ನ ಆಬ್ಟೈನ್ ಮಾಡ್ತೀವಿ. So these were the important reaction one can able to see in that of your contact process. But in case if you have to see how it is undergoing in the industry process, here is your diagram. So let us have a look of this diagram. So basically idru ಮೂಲಕ ಇಲ್ಲಿಂದ ನಾವೇನ್ ಪಾಸ್ ಮಾಡ್ತಿದೀವಿ, ನಮ್ಮ ಏರ್ ನ ಪಾಸ್ ಮಾಡ್ತಿದೀವಿ. Okay, as your air. So whatever the part you can see over here, you can just see this is your sulfur. Okay, first part ಏನ್ ಮಾಡಿದ್ವಿ ನಾವು, ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀವಿ, ದ ಇಂಪಾರ್ಟೆಂಟ್ ರಿಯಾಕ್ಷನ್, ಫಸ್ಟ್ ಬರ್ನಿಂಗ್ ಆಫ್ ದಿ ಸಲ್ಫರ್ ಟು ಜನರೇಟ್ ಯುವರ್ SO2. ಸೊ ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಹೋಗ್ತಾ ಉಂಟು, ಇಲ್ಲಿ ಸಲ್ಫರ್ ಉಂಟು, ಫಸ್ಟ್ ಏನ್ ಆಗ್ತಾ ಉಂಟು ನಿಮ್ಗೆ ಫಾರ್ಮ್ ಇಂಪ್ಯೂರ್ SO2 ಅಂಡ್ O2. ಫಸ್ಟ್ ಇಟ್ ಇಸ್ ಪಾಸ್ ಟು ಅ ಡಸ್ಟ್ ಪ್ರೆಸಿಪಿಟೇಟ್. ಯಾಕೆ ಇದು ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಏರ್ ಅಲ್ವಾ, ನಾವು ಪಾಸ್ ಮಾಡ್ತಾ ಇರೋದು, ಸ್ವಲ್ಪ ಡಸ್ಟ್ ಅಮೌಂಟ್ಸ್ ಎಲ್ಲ ಇರುತ್ತೆ, ಅದನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ಈ ಡಸ್ಟ್ ಪ್ರೆಸಿಪಿಟೇಟರ್ ಹತ್ರ ಪಾಸ್ ಮಾಡ್ತೀವಿ. Dust precipitator ಏನ್ ಮಾಡುತ್ತೆ, whatever the dust will be there, it will all get precipitated and it will pass the remaining SO2 and O2 over here. So that SO2 and O2 is first what we will doing, water spray. ಏನಾದ್ರು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ರೆ ನಿಮ್ಮ ಗ್ಯಾಸ್ ಮೇಲೆ ಅವೆಲ್ಲ ಇಲ್ಲಿ ಸೆಟಲ್ ಆಗಿ ವೇಸ್ಟ್ ವಾಟರ್ ಜೊತೆ ಹೊರಗೋಗುತ್ತೆ. ಒನ್ಸ್ ಅಗೇನ್ ಅದನ್ನ ಪ್ಯೂರಿಫೈ ಮಾಡಿದೀವಿ ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಒನ್ಸ್ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಪಾಸ್ ನೌ ಟು ವೇರ್ your concentrated H2SO4. Why? Because ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಮಾಯ್ಸ್ಟ್ ಆಗಿರುತ್ತೆ ಆ ಗ್ಯಾಸ್. ಓಕೆ, ಸಿನ್ಸ್ ವಿ ಆರ್ ಪಾಸಿಂಗ್ ದಿ ವಾಟರ್, ಸೊ ಕಾನ್ಸಂಟ್ರೇಟ್ H2SO4 ಮೂಲಕ ಏನ್ ಮಾಡ್ತೀವಿ, ಅದನ್ನ ಡ್ರೈ ಮಾಡ್ತೀವಿ. ಯಾವ್ದನ್ನ, SO2 ಮತ್ತೆ O2 ನ. ಈಗ ಡ್ರೈ SO2 ಅಂಡ್ O2 ನ ನಾವು ಯಾವ್ದ್ರ ಮೂಲಕ ಪಾಸ್ ಮಾಡ್ತೀವಿ, ನಿಮ್ಮ ಆರ್ಸೆನಿಕ್ ಪ್ಯೂರಿಫೈಯರ್. ಒಂದು ವೇಳೆ ಎಲ್ಲಾದ್ರೂ ಈ ಡ್ರೈ SO2 O2 ಜೊತೆ ಆರ್ಸೆನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇದ್ರೆ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಅನ್ ಇನಿಬಿಟರ್, ನಿಮ್ಮ ಈಲ್ಡ್ ನ ಕಮ್ಮಿ ಮಾಡುತ್ತೆ. ಸೊ ಅದನ್ನ ತೆಗೆಯಕ್ಕೆ ನಾವು ಆರ್ಸೆನಿಕ್ ಪ್ಯೂರಿಫೈ ಮೂಲಕ ಕಳಿಸ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ವಿ send to that of your preheater, ಸ್ವಲ್ಪ ಅದನ್ನ ಹೀಟ್ ಮಾಡ್ತೀವಿ. Once you have what you can say completed this much, now the process starts. Now what you're going to do, you're passing your SO2 and O2 to that of your catalytic chamber which is having that of your vanadium pentaoxide. So illenagutte, the catalytic oxidation of your SO2 to SO3 takes place. So here now SO3 comes out. Now what I am passing to a concentrated H2SO4. Whatever the SO3 is obtained, now it is getting absorbed in your concentrated H2SO4 to get the final part, that is your oleum, that is H2S2O7. So once you got the oleum, as I have mentioned, you can dissolve it in the quantity of the water required to get the perfect concentration of your sulfuric acid. As I have mentioned, here in this case, the maximum extent or the maximum percentage of the concentration of sulfuric acid you are going to obtain will be 96 to 98%. Is that clear? So these were the important part of your preparation of your sulfuric acid, and this was your flow chart in the manufacture of your sulfuric acid. So now let us check out the properties of your sulfuric acid. properties of sulfuric acid. So whenever we deal with the sulfuric acid, again and again we always say that your sulfuric acid is the king of chemicals. What is the reason for this? Why? What has made the sulfuric acid to be called as the king of chemicals? So there are certain characteristics which are only shown by that of your sulfuric acid. First important characteristic of your sulfuric acid is, first of all, it is low volatile. What we are saying, it is a low volatile, means it will not get evaporated very easily. Second one is about its strong acidic character. Strong acidic character. Okay. ಯಾಕೆ ಸ್ಟ್ರಾಂಗ್ ಅಸಿಡಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅನ್ನೋದಕ್ಕೂ ನಾನು ರೀಸನ್ ಕೊಡ್ತೀನಿ. ಫಸ್ಟ್ ವಿಲ್ ಜಸ್ಟ್ ಸಿ ವಾಟ್ ಆರ್ ದಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್. ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಸ್ಟ್ರಾಂಗ್ ಅಫಿನಿಟಿ ಫಾರ್ ವಾಟರ್. Strong affinity for water. That is the reason we called sulfuric acid as a best dehydrating agent. Alva water molecules na easy agi tegbidutte because your sulfuric acid is loving water very much. And also it acts as an oxidizing agent. It also acts as an oxidizing agent. So this is the one acid where you can see all these characteristics, which is very much important to carry out any reaction. So as I mentioned over here as one of the important characteristics, that is your strong acidic character. In order to understand this, first of all we have to see how does your sulfuric acid is present in water. How does it ionize in water? Do remember your H2SO4 in presence of water is ionizes 2 times. Okay, in 2 steps it is going to ionize. First of all, of course, it is going to give as a hydronium ion. Along with that ion, you are getting as a HSO4 minus. So this HSO4 minus do not remain as such. This HSO4 minus, once again, it is going to react with the water to get that of your, once again, a hydronium ion plus that of your sulfate ion. You could just see that 1 mole of the sulfuric acid is providing you 2 moles of the H plus. So as the concentration of the H plus is increasing, what happens to the acidic character? Of course, it also increases. So that is the reason we say that your acid is having a, your sulfuric acid is having a strong acidic character. Not only that much, since utilizing the property of its low volatility, okay, using the property of its low volatility, even your sulfuric acid is utilized to the manufacture of your volatile acids. I'll give you the general formula. So whenever your Mx plus that of your H2SO4, it gives you that of your Hx plus of M2SO4. Here your X are generally fluorine, chlorine and that of your nitrate. Okay. So yavagli agi FCl and HCl. For example, MF or MCl, any part you can just consider. So yavaga nima HF or HCl ivella ನೀವು ತಗೊಂತೀರಾ, they are mainly somewhat volatile they are. ಸೊ ಈ ತರ ಒಂದು ಆಸಿಡ್ ನು ಕೂಡ ನಾವು ಏನ್ ಮಾಡಬಹುದು, H2SO4 ಮೂಲಕ ಈಸಿಯಾಗಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ. ಕಮಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟಿ, ದಟ್ ಇಸ್ ಇಟ್ಸ್ dehydrating agent. Dehydrating agent. Of course, many of you have seen this experiment in your lower classes. So whenever you put a strong sulfuric acid to the sugar, you will be obtaining some black mass, which is called as what? Charring. Which is called as what? Charring. ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಬೇಸಿಕಲಿ C12H22O11, that is your sucrose. Whatever it is present in sugar cane, ಏನ್ ಶುಗರ್ ಅಂಶ ಇರುತ್ತೆ ಅದನ್ನ ನಾವು ಸುಕ್ರೋಸ್ ಅಂತೀವಿ. ಸೊ ಇದನ್ನ ನೀವು ಯಾವಾಗ ನಿಮ್ಮ H2SO4 ಜೊತೆ ಹಾಕ್ತಾರೆ ಏನಾಗುತ್ತೆ, ನಿಮ್ಗೆ 12C ಸಿಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್, ದಿಸ್ ಕಾರ್ಬನ್ ಅದೇ ಬ್ಲಾಕ್ ಮಾಸ್ ಏನ್ ಬರುತ್ತಲ್ಲ, ಬಟ್ ಮೇನ್ಲಿ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಯೋರ್ ಕಾರ್ಬನ್. ಅಲ್ಲಿಂದ ಏನಾಗಿದೆ, ಯಾಕೆ ಇದು ಬರ್ತಾ ಉಂಟು ಅಂದ್ರೆ, ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಕಿಕ್ಡ್ ಔಟ್ ದಿ 11 ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಔಟ್ ಸೈಡ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಿತ್ತು H2O ಕಾಂಪೋಸಿಷನ್, ಅದನ್ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ತೆಗ್ದಿ ಏನ್ ಮಾಡ್ತಾ ಉಂಟು, ಸಾಲಿಡ್ ಕಾರ್ಬನ್ ಕೊಡ್ತಾ ಉಂಟು. ಸೊ ಆ ರೀಸನ್ ಇದನ್ನೇ ಅವ ಬ್ಲಾಕ್ ಮಾಸ್ ನ ನೋಡೋದು, ಚಾರಿಂಗ್ ಆಕ್ಷನ್ ಆಫ್ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ನ ನೋಡ್ತೀವಿ. ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಡಿಹೈಡ್ರೇಟಿಂಗ್ ಏಜೆಂಟ್ ಇಸ್ ದಿ charring of your carbohydrates. Not only that much, even it acts as an oxidizing agent, I have said. Okay, it oxidizes both of your metals and the non-metals. You can see the reaction. So whenever your copper is reacting with that of your H2SO4, concentrated H2SO4, basically it oxidizes your copper to copper sulfate. Along with that one, you'll be getting as an SO2 plus that of your water. We will balance this SO4, H2O, since here 2S, 2H2SO4, 2H2SO4 ಹಾಕಿದಾಗ ಇಲ್ಲಿ ಈಗ 2 2s are 4, 2H2O. Not only that much, even that of your non-metal, that is your sulfur, when it is reacting with that of your H2SO4, it gives you as an SO2 plus that of your H2O. So SO2, so 3S, 2SO2. Sorry, 3S, 3 plus 1. So basically you will be obtaining as a 3SO2 itself, 3SO2 plus H2O. Balance agidya? No. Here comes what? 2H2SO4. So here 2 water. So 3S plus 2H2SO4 gives you as a 3SO2 plus 2H2. Look what sulfur has been oxidized to that of your sulfur dioxide. Similar is the case when you treat your coke or carbon with that of your H2SO4, it will be getting oxidized to that of your carbon dioxide plus SO2 plus that of your water. So these are the important reactions which is indicating the oxidizing property of your sulfuric acid. So what were the important properties? First of all, we came to know that why your sulfuric acid is called as the king of chemicals. The main reason is because of the following characteristics: low volatility, strong acidic character, strong affinity of water, and oxidizing agent. So when we are calling it as a strong acidic character, here I have shown you that 1 mole of your sulfuric acid, when it is treating with that of your water, it is giving you the 2 moles of your H plus or a hydronium ion. So as the concentration is increasing of your H plus ions, of course we know that acidic character also increases. Similarly, the most important property of your sulfuric acid is because of its low volatile nature, it is also able to manufacture your volatile acids like that of your HF or HCl, all those parts. Coming with respect to the dehydrating agent, one common example which we have seen even in our lower classes is about charring of your carbohydrates. By treating, whenever you put the constant sulfuric acid to the sugar, you could just see a black mass emerging out. So that black mass is actually your solid carbon, which is obtained by removing the water molecules from that of your, which has happened because of the use of your sulfuric acid. Then comes the oxidizing property. So your sulfuric acid oxidizes both of your metals as well as the non-metals: copper to copper sulfate, sulfur to sulfur dioxide, and carbon to carbon dioxide. So these were some important aspects of the group 16 elements of the sulfur. So in today's scenario, we have learnt about the allotropes of the sulfur, oxides of the sulfur, oxoacids of the sulfur, and that of your sulfuric acid. Sulfuric acid, when we have seen that how we are going to manufacture your sulfuric acid by the contact process. What were the 3 important reactions which is occurring in the contact process? Among those 3 reactions, which was the most important? It was the catalytic oxidation of your SO2 to SO3 in the presence of vanadium pentaoxide catalyst. So in our next session, we are going to see the group 17 elements.